we're going to do part 2 of lesson 2A5, and that's going to be on the Descartes rule of signs and associated theorem. So we want to review a couple of tidbits first. First one is, given an nth degree polynomial, you can have at most n real zeros. So if you have x to the fourth as your polynomial, fourth degree polynomial, you can have at most 4 real zeros. You can have less than that, but you can't have more than 4. I mean, you just have 4 or less. The next one, which is crucial, is imaginary roots always come in pairs, conjugates. So let's go back to that fourth degree polynomial. You can have at most 4 real zeros, but you can have less. But you're not going to have 3 real zeros because that implies that one of the zeros has to be imaginary, but they come in conjugates. So you can either have 4 real zeros, 2 real zeros, or no real zeros because of this definition right here. And this leads us into Descartes' rule of signs. And it's interesting because he made fun of the Italians a little bit for coming up with imaginary numbers. But then he does this rule, which implies you have to have imaginary roots. Okay, so let's take a look at what it says. The number of positive real zeros of f, the function f, is either equal to the number of variations of signs of f of x, or less than that number by an even integer. You're going to read this twice and go, huh? But you're going to see it when we do the example. And conversely, the number of negative real zeros, we're talking real zeros here, is equal to the number of variations of signs of f of negative x, or less than that number by an even integer. So we're first going to take a look and say, okay, what's going on? Let's take a look at a basic example here. So here I have 3x cubed minus 5x squared plus 6x minus 4. Notice how the sign changes from positive to negative, and so on. Well, we can construct that. So when we're going to do Descartes' rule of signs, we want to construct what is called a Pni chart. But we also want to go ahead and do our f of negative x to determine the negative possible roots. So when I put in negative x, that's cubed. So when we have an odd powered, it's going to change the sign to negative 3x cubed. Even is going to stay the same. Okay, so we're going to have negative 5x squared. Odd is going to change it, so it's going to be negative 6x minus 4. And I'll go ahead and draw a Pni chart. I call it a Pni chart because I have my positive, negative, imaginary, and total. Total is, using the fundamental theorem of algebra, we're going to have at most 3 roots. Okay, we're going to have 3 roots. All right. So let's take a look at the sign changes on our positive. We go from positive to negative, negative to positive. So that's 1, that's 2, and then we go from positive to negative, that's 3. We have 3 sign changes. Well, we have 3 total roots, so that means we have no negative and no imaginary roots. That's one scenario. Our next scenario is, let's take a look at what's going on with our negative roots. We have no sign change, no sign change, wait a second, oops, I might have did that wrong, and no sign change. No sign change. Yep, no sign change. So we can have 3, 1, and that's it. We can't subtract another 2 because you can't have negative. All right, so we're going to have 0 imaginary. Oops, I did that wrong. I'm off in la la land. I have 2 imaginary, total 3. So this is my scenario. I can have 3 real positive roots, 1 real positive root, and 2 imaginary, but none of them are going to be negative. Always 3 over here for the cubic. One more example. So again, I'm going to go ahead and do my f of negative x. Go ahead and do that. That's going to change the sign to negative 2x cubed. That's going to stay the same. That's going to change. And that's going to stay the same. Let's do my Pni chart. Positive, negative, imaginary, and total. My total is going to be 3 for both of these. So let's take a look at our positives. We have a sign change. Nope. So that's not a sign change. We have 1 sign change, 2 sign changes. So I have a possible of 2. And I can subtract, and I'm going to have a possibility of 0 here. Let's see what's going on with our negative. We have 1 sign change, none, none, none. So we only have 1 sign change here, and we have 1 sign change here. That leaves us with 0 imaginary on this scenario, but 2 imaginary roots on this one. Now, if we were to further dive into it, we can say, what's all our possible roots? So we have plus or minus 2, and plus or minus 1 as the factors of 2 here, and the same thing here, plus or minus 2, plus or minus 1. All right? So our possible roots are going to be just 2 over 2 is 1. So plus or minus 1, plus or minus 2, plus or minus 1, plus or minus 2, and plus or minus 1/2. Well, that gives us 6 possible roots. I'm going to bet that we're going to check the positive ones before the negatives if we're to do synthetic division. So it helps narrow us down. We have another tool. Let's take a look at that. And this is called the upper and lower bound theorem. All right. And it's just a test to see, okay, if I gave you something with like a factor of 20 or a factor of 40, you can get a whole bunch of possible zeros. And you may want to try and narrow it down. It's like looking for something in your house, search and rescue or whatever. Narrow it down as much as possible. So let's see what this says. So we have a polynomial of degree greater than 1, so it's not linear, it's quadratic, cubic, whatever. And it has to have a positive leading coefficient. So suppose we do synthetic division, and we get, if we're doing a positive number in a synthetic division, and we have every number is non-negative, basically our answer is all positive, then we found an upper bound. That means we're not going to have any zeros greater than that number. And conversely, if we pick a negative number to do synthetic division on, and the last line is alternately positive and negative, then we found a lower bound. So let's try this out. We got a whole bunch of possible zeros. We got plus or minus 6, plus or minus 3, plus or minus 2, plus or minus 1, all over, well, fortunately, just plus or minus 1. So that gives us plus or minus 6, plus or minus 3, plus or minus 2, plus or minus 1, all right, as our possible zeros. That's 2, 4, 6, 8 zeros. We're going to have at most three real number ones. So odds are less than 50% that if we randomly pick one of these, we're going to get a real solution. And it could be significantly lower than 50% because we only have one real solution on this particular cubic. So imagine if I just said, I'm going to say, let's see what -1 brings us. This could be an upper or lower bound. We don't know. And I do the synthetic division, -6, 11, and -6. I'm going to bring down that 1. I'm almost out of space. So I'm going to 1 times, that's going to be -1. That's going to give me a -7. Okay. That's going to give me a positive 7. That's going to give me 18. So that's going to give me a -18. And that's going to give me a -24. Look how these alternate. Positive, negative, positive, negative. I have a lower bound. So I know that, and plus this is not a 0, by the way. So I have a lower bound. So all my roots are going to be bigger than -1. So I struck out just half of them right off the bat. So I got 1, 2, 3, and 6. So now I can go ahead and try and solve for this thing. All right. So we have possible zeros now are just 1, 2, 3, and 6. Because we wrote out all the other negative ones because we found a lower bound. So I'm going to go ahead and start dividing. I'm going to use 1 because I want to find all my things. So I'm going to have 1, -6, 11, and -6. And this is just a technique. You can always do guess and check from the start. And let's go ahead and drop this. So we got 1. 1 times 1 is 1. So that gives me -5. 1 times -5 is -5. That gives me -6. 1 times -6. I did something wrong, didn't I? Yes, I did. That should be a positive 6. Yep. All right. And that's a positive 6. And that's going to give me a 0. All right. Okay. So we have a root of x is equal to 1. So I know that x minus 1 is a root. And that leaves me with x squared minus 5x plus 6. Well, that's easily factorable. I can still use quadratic formula. So what times what is equal to positive 6, and that together gives you -5. And that's nothing more than x minus 1. And that's going to be -2 and -3. So there you go. So I have x is equal to 1, x is equal to 2, and x is equal to 3. And I could go ahead and plot these zeros, do my end behavior, and know that I have multiplicities of 1 on all these, and sketch the graph. Okay, last thing. Putting it all together. So here's what I'm talking about. I have 120. So if you try to do all the possible roots, plus or minus 120, plus or minus 60, plus or minus so on, 30, 40, 10, 5, 2, 4, whole bunch of them. And this is 1. Imagine if that wasn't a 1. You're going to have a whole bunch of them. So what we do in this accelerated course of ours is that if we do give you one of these problems, we're going to let you use the calculator on this. Now you're going to have no calculator portions on your test because we do expect you to do pretty much this almost the entire course without no calculator. Because, you know, my daughter is a testament. She is in the A&M system, and her freshman pre-cal class was completely no calculator. So what you can do, though, in our courses is go ahead and put this into your Y1 editor, put in the function, and then go to your table and look for zeros. We got a -6 and we got a positive 5. So those are our two zeros. X is equal to -6 and X is equal to 5. I didn't see any others. There could have been more. We have 4 possible real solutions. All right, but I didn't see any. They could probably be fractions or something. Who knows? All right. So what we're going to do is now that we have that, and I already got it started because I knew this video was going to be a little long, is that we're going to go ahead and solve for the other missing zeros. We got X is equal to -6, okay, and we got X is equal to 5. So we know those two zeros. So let's go ahead and knock it out. So we have -6. That's going to be -6 right here. And we're going to drop that. That gives me -5. That's going to give me a positive 30. That gives me a 4. -24 gives me a negative 20. I got to watch out for that. And that gives me a positive 120, which gives me a 0. Okay? Knock that one out. So now we're going to do 5. And we're going to put it into this one. This is going to be cubic now. So I'm just going to go, remember, this is x cubed minus 5x squared, so on, okay? So I'm going to have 1, -5, 4, -20. And I could have just put the 5 right here and continued on the process. And I'm going to demonstrate that in class. All right, drop the 1, and I didn't do that. Let's clean this up a little bit. Here, I had to have sound effects. All right, I'm going to drop the 1. So I got 5 times 1 is 5. That's going to be 0. All right. And that's going to give you 0. And this is going to give you a 4. And that's going to give you a 20. And that's 0. All righty. So I have basically this. I have x plus 6 times x minus 5 times, this is x squared. And that's going to be a 4. X squared plus 4. X squared plus 4. All right. So this is, of course, is not going to be factorable. I can use quadratic formula, but I'm going to use a square root method. X squared is equal to -4. Therefore, x is equal to plus or minus square root of -4, which is plus or minus 2i. All right. So we have our roots. We have -6, 5, and plus or minus 2i. Those are our 4 roots. Alrighty, I'll go ahead and get this posted. This was a little bit longer, but you can pause and work these examples as you see fit.